Hi, everybody. Welcome to our deep dive webinar on the VoltScript Early Access that is now available. I'm Adam Gartenberg, Director of Product Management for VoltMX Go, and I'm pleased to be joined today by Paul, Ed, and Bob from the team creating VoltScript, and they're going to go into all the details and demo what's available. As a reminder, please put your questions into the question panel in the sidebar at any time, and we'll answer them at the end of the session. So this is the last session in our scheduled series on VoltMX Go. You can see all of the sessions we've had here. Hopefully you've been able to join us for at least some of them. If there are any that you missed, the replays are all available on YouTube. You can scan the QR code there and that will take you to them, or you can go to the HCL Digital Solutions YouTube page and you can find a playlist with all of them there. We're also going to have a session coming up on VoltMX Go 201, so keep your eye on your email for registration details on that once they are available. And before we go into all the details on VoltScript, a quick reminder, and for any of you who might be new, just a quick refresher on VoltMX Go as a whole. So VoltMX Go will help you extend and modernize your Domino applications or even create entirely new ones connected to your Domino backend. And that means you can create native mobile, tablet, desktop, and wearable apps. You can bring in capabilities like AR, VR, AI chatbots, and IoT, as well as integrate with any other backend system. As you're hearing today, it'll also allow you to maximize and future-proof your skill investment by allowing your Domino developers to bring their code into VoltMX applications, and also allowing you to tap into the pool of JavaScript developers available in the marketplace today. And then lastly, you can do all of this while automating and saving up to 60% of the labor needed to modernize your apps. And that means you can reduce the cost, time, and risk involved in doing so. And so with that, I will turn it over to Paul to start taking you through all the exciting stuff around VoltScript.
Thank you, Adam. So, welcome to today's webinar. So I wanted to start off with a bit of background. So what is VoltScript? Well, at its heart, it is the LotusScript language engine. That means no notes classes, no constants. It's just the language engine itself. And it's been extracted from Notes and Domino. So it's running standalone outside the product for the first time since the 1990s. Obviously, because it's outside of the product, it's not running design elements in an NSF, it's running files. So that means .vss files, but it will also work for .lss files as well. Obviously, you're going to need to have classes to do much of your processing. And so we contribute a number of VoltScript extensions, which I'll talk about shortly. And those are coded in C and C++ and often using underlying platform libraries like libcurl. We've provided some of those, but we hope that customers and business partners will also contribute some as well as the ecosystem grows. But obviously that requires a very niche skill set of understanding C and C++. There are many LotusScript developers out there who have contributed LotusScript code on OpenNTF over the years. So we can also open source VoltScript library modules as well. We are open sourcing some as part of EA1. And again, we hope that customers and business partners will contribute others as well in the future. Obviously, we also need an IDE to write the code in. If you're a real masochist, then you could go for Notepad, but we recommend VS Code. We've got some extensions that integrate with that, as you'll see. And obviously, when it comes to Foundry running in a browser, that's going to mean the Monaco editor, which is part of VS Code. You'll be coding locally, testing locally. Obviously, because there's no Notes session or Notes UI document, no Notes UI workspace, there are going to be variables that you need to pass into that code. And as a result, we can pass and receive context in your code for running configurable code. Initially, we'll just be running standalone, but as we get closer to GA, then it'll be possible to deploy those REST services and write snippets of code up on Foundry, and those will be triggered as REST service calls. So just some parallels and differences between LotusScript and VoltScript. So first off, LotusScript typically runs where both the data and the UI are. VoltScript, because it's designed to run on Foundry, is separate from where the data is, and it's separate from where the UI is. And it's important to bear those in mind when you're thinking about what code you would write and how you would interact with both the user and the data. Obviously then LotusScript has front-end classes, VoltScript doesn't, and it won't. LotusScript, we're familiar with script libraries and LSXs. We may not be aware of them as LSXs, but all of the Notes classes and the Notes backend classes come from the first ever LSX, LSXBE. We've got the same concept in VoltScript with VoltScript library modules and VoltScript extensions. We've talked about the IDE, but obviously that LotusScript is stored in CD records in the notes, and it's compiled and saved as a .lso file within that note when you save. VoltScript, it's just stored as files on your file structure, plain text files in with a .vss suffix, and it's then compiled and run at runtime. LotusScript is 32-bit and 64-bit, 64-bit for the server, 64-bit for version 14. VoltScript is 64-bit only. So we've had a number of touchstones that we've focused on as we've developed VoltScript. The top one there, simplicity, was one that Jason charged us with from the early days. LotusScript was an approachable language for citizen developers. I myself came from a non-IT background, learned LotusScript after I'd gone into formula language and picked it up. And we want to keep that going forwards. We don't want to make this as complex as something like Java, for example. And it needs to be approachable, not just for LotusScript developers, but Visual Basic developers. Maybe there's some JavaScript developers who want to leverage some functionality that they can do in Foundry with VoltScript that they can't do with with JavaScript. But LotusScript has a number of rough edges, some quirks to it, and we try to iron those out to give greater consistency as we go through the development experience. And that development experience, we want it to be modern. The world has evolved quite a bit over the last 20 years, and so we want to leverage that. Extensibility was at the core of LotusScript, and we want to keep that at the core of VoltScript as well, and we want it to be fun. So let's go into some demos. So first off, you're going to need to install it and get started. And most Domino developers, their operating system is Windows, and so we've got a zip file that you can get started with on Windows. So as I say, that comes as a zip file, VoltScript ea1.zip, and that just needs unzipping to a location on your file system. I've used C program files VoltScript. The next step is to add that to the path environment variable. Easiest way I've found to do that is click on the Windows menu, type env, gets to the environment variables, and it's under the system path one that we need to add that. And then we're ready to start coding. So as I say, Visual Studio Code is what we use. Visual Studio Code uses all sorts of extensions, and we've got 2 extensions for VoltScript. So we go to the extensions area. They're not up on the marketplace yet. This is still early access, so you need to install them from the VSIX. And those are delivered as part of that zip. So you just need to go to the location that you unzipped, select them both, install, and then reload. And at that point, we're ready to start coding. But you're going to want to know what you should be coding with. So we've got our documentation, and under the references area, we've got a list of all the new language features, which Ed will be going through shortly. We've also got the list of the VoltScript extensions that we deliver. So we've got context VSE for handling a simple string being passed in, stream VSE for accepting more complex data via standard in and standard out, as well as reading and writing files as you're familiar with NoteStream. OS utils to handle dealing with the operating system in an easier way. So you don't need to worry about catching error 76 when you make a directory because it already exists. OS utils will just easily handle that, and it handles building up paths in a nice usable way. Zip VSE for handling zip files. Obviously, as you're running as middleware in Foundry, probably upwards of 90 to 95% of the data that you're dealing with will be JSON. So we need some nice classes to be able to handle that, as well as for making for web calls with web VSE. Obviously, dates aren't going to come in as notes date times in JSON. They're going to be coming in as UTC, so we've got Zulu VSE for handling that. And hash VSE for encoding data and using SHA-256 keys and those kind of things. And of course, dealing with backends, we've got Keep VSE for dealing with Domino REST API and Couch VSE for talking to Couch. Now, for all of these, if you click on the links, you'll get the full API docs. And we've also got an aggregated API doc as well, which gives us full documentation for all of those classes. So we can drill into JSON VSE, for example, look at the JSON parser and see there's a load from JSON method, and we can see the arguments that it takes, the errors that it might throw, and some sample code as well. Now, for getting those VoltScript extensions, those are being hosted up on the HCL VoltMX marketplace. If you search there for VoltScript extensions, then they're all available there. And you can download them and set those up manually. But I'll talk about an easier way to deal with that in a few moments. The library modules, we've got one for unit testing, which has been public for a while, JSON converter for automatically serializing and deserializing JSON, like you do with Google JSON in Java, VoltScript collections, and console colors. Those are open sourced, and they've got their own repos up on the HCL Tech Software GitHub, as well as their own documentation with how-to guides to talk through how to do various bits. But we've also got how-to guides for the core language and for the VoltScript extensions that you can drill through. And as you look at those, you can see the code to use for doing certain functions. And we've also got a link across to samples on GitHub. And that repo is open source as well, so that you can look at the individual code. But you can also download that whole repo and get working with it yourself. And that's what I've done here. I've got the downloaded repo, I've extracted it, and we can now open that up in Visual Studio Code. Now, you don't open up the top level. If you follow the README, you'll see all the details about that. You open up each individual project. And at this point, we've got the project. We can look at the code, but we've then got an error here, and that's because we don't have that JSON VSE dependency. We've added in dependency management to allow you to pull down dependencies. So actually, that requires the atlas.json. This basically does specifies what the dependencies are, where to get them from, and what your project structure is. Obviously, you need credentials for those repositories. That's stored in your user directory in a .vss directory, and it's the Atlas settings. And then we can put the GitHub personal access token, username and password for VoltMX, or we can store them in environment variables. This is all covered in the documentation. But once we've got that, then from the atlas.json, we can go to VoltScript install dependencies. We give it the path for the project. It picks up the Atlas settings because it's in the .vss directory. It picks up an atlas.json in that project file, and then we can tell it whether to force downloads or not. It builds our project directories. It goes and downloads from GitHub and from the VoltMX marketplace, extracts those zips and puts them into our project here. So we've now got the JSON VSE there, and in libs we've also got VoltScript testing. And now when we open it up, it's all fine. We can actually run those individual functions as well. So if I go to the unit testing one, I can do Control-Shift-P and VoltScript save and run script. And it runs that script and it generates unit tests. And those unit tests can then be opened in the default browser. And if you're used to JUnit, these will look very familiar. So that's just an overview of getting started and running your first sample. Now I'll hand on to Ed for the next demo.
Thanks, Paul. So let's start screen. All right. So as part of the modernization of the language, we added a few language features that are part of the modern languages. Some of the new features that you will find in VoltScript for a better error handling is the try and catch and finally that probably most of you are familiar with that. And also we added a new way to return value with on functions without using the assignment to the name of the function. It can be used also as a substitute for exit sub and exit function. We added also a new set of operators, also part of the modern languages like post increment, pre increment, plus equal, minus equal, and so on. And also we added a new built-in function, create UUID, which is really useful for storing unique identifiers in databases, for example, in CouchDB. So let's start now with VS Code. So I have here a VoltScript script I have here the output of that script, and let's go through the quick through the output of the script and see what's going on with the new language features. So we have the TS, the try and catch and finally test. We have here, for example, error 1 at line 14. This line here. This is basically throwing this error and is being caught by this catch block, and then we print the string. We have error 2 in line 22, which is this one in this particular case, is caught by this catch block, and we have here a finally block that what it's doing is basically executing this statement, those statements that are part of that block, as you can see here. So if you have something that fails and you have caught, or even if you haven't, there will be always this last step that will perform whatever the script has to do. For example, closing a database connection or whatever. Moving on, we have error 3, line 32. Let's see this try block. So in this particular case, we don't have any error, but we have a general catch. So anything will be caught in this catch block, as you can see here. Now, there is something that is specific and that we are, that is not part of try and catch in JavaScript, Java, or C++, and is the ability to catch the exceptions when a particular condition is met. So, for example, in this case, we set the condition to true, and then we can see that the error is caught in line 44. So this is the error, and is caught because the condition is met. Let's see what happens if the condition is false. So in this case, we set to false, we throw the error, and we are catching the error in this block because this condition is false. So the error keeps flowing till the next catch, which is this one. Now, try and catch blocks can be nested as well, and we have an example here. So we have error 2, line 64, which is this one. So what happens here is this function is failing, is throwing an error, but it's not being caught by this try and catch block for some reason, which is the inner one, but is caught by this outer block. And this is a summary of the try and catch and finally error handling. If you are familiar with JavaScript or Java or C++, you probably find this really similar. So let's move on now to the return, to the improved return statement. So we have here a simple function to compute the factorial of a number. And you can see here the way that we can now return a value from a function. We don't need to assign the value to the name of the function anymore. We can just use a simple statement. If x equals 1, then return 1, else return x by factorial x means 1. So that helps to write less code and a simple code. Here you can see the output of the function when running with 3. Now let's see the following two functions, which is the new way that return works. You can even use return without any value. So let's say that you need to leave a particular sub or a function. You can just do return, and then it will stop the execution of the function, and it will return from the function. And you can achieve the same behavior from a loop. So now let's move on to the new operators. We added post increment, pre-increment, post decrement, and pre-increment. Here you have the output of this loop, which is basically printing 1, 2, 3. Here we are incrementing using post increment. Same thing, 3, 2, 1, 3, 2, 1, but using pre-decrement. We have also new assignment operators using plus equal, star equals, minus equal, or slash equal. This is the real division. This is the integer division. And you can see the output here. So we add 3, we get 3. By 3, we get 9. Minus 9, we get 0. If you use division, the real division, we get 4.5. And if we use the integer division, we get 4. Now, let's move on to the lazy evaluation. We improve the logical operators, the OR operator and the AND operator. As you know from VoltScript, all the condition is evaluated, all the expressions are evaluated. We change that, and we are only evaluating the expression if it's required. So in this case, for example, using the traditional OR from VoltScript, the expensive operation is this one, is run. Even if there is here a true expression, an expression that is evaluated to true and is not required to run this expensive operation, but because all the expressions are evaluated, we run the expression. Now we change that, and if you see here, this function returns true, and because of that, the sum expensive operation is not executed, is not run anymore. Same goes for the AND operator. Because this is false, right? This is returning false, then the expensive operation is not executed. And you can achieve the same behavior, but you have to type and use else if. And last, we have the UUID test, which is basically the output of this function that brings out, in this case, 4 UUIDs, version 4, that you will find useful for, as I said, dealing with databases. And that's all I have. Handing off to Bob now.
Thank you, Ed. I'm going to share my screen. Okay, I'm going to do a little demo script here for something a little bit involved. I'm going to take the Notes backend classes, bring them into VoltScript here, the old use LSX statement, and using the couch VSC that exposes an object model for CouchDB, I'm going to copy documents out of NSF into Couch. Just show that it can be done. So I have a bunch of constants here, couch URL, the couch database name, the Domino server is running locally. Actually, it doesn't even have to be running, but I'm going to pull LSXBE from there. I'm going to do a loop of 10 documents from this NSF and this view. So you can see here, this should be all very familiar. No session database view document. I have a new couch server and a couch database instance. I'm going to connect to the couch database. I set the URL, the user, and the password to these constants, and then I say log in, then I'm connected. On the Couch server, I can test to see if my database exists. If it does, I'm going to get it. Otherwise, I'm going to create it. It already does exist. I get the notes database using session get database. Test that it's open, which it will be. I get the view that I want, and then I start a loop, a standard get first document, get next document loop over 1 to 10. Make sure that it exists, and then I'm going to call a copy to couch function here. I'm passing the document instance, the CouchDB instance, and the counter. And that's right here. So I'm going to create a new couch document. I'm going to form an ID for that document from the word doc and the index. Could be anything you want. If you don't want to make one up, you can use a UUID that Couch will generate for you. If the document already exists in the database, I'm going to delete it and recreate it. So I say create document with that ID. I'm going to get all the items out of the notes document. That'll come back as an array of notes item. I'll show you how many I found. And then loop over each item. Most of the time, I'm just going to copy the values here to the couch document with the add item data call. But if it's a notes date time, then I want to convert it from the LotusScript date value to an ISO date string, which I have local code for that. I'm not going to bother showing it to you. And once I've done all the item copying, I'm going to add the universal ID and create an couch date time stamp to the couch document and save it to couch. And so on. Just do that. So inner loop. I'm going to run this with Control F5. No options. And you can see it's fairly fast because I'm running couch locally. If we were going with the network, it would be a little bit slower. I'm going to quickly go over to the couch. Whoops. Sorry. I didn't preload this. Bad. DRM is the database I created. And here you can see my 10 documents. I'm going to pick doc 4 just to show you what it looks like in Couch. And it's all been converted to JSON. You can see from the dollar items in Notes, we create a meta sub object here. Rocky created this document in the original database. I just want to point out the nickname here has an accent in it, Noemi, showing that we've converted the Limbix text to Unicode successfully. And I think that's the end of that demo. So I'm going to hand the speaking stick back to Paul.
Bob, let me just share my screen again. Thanks, Bob. So for the last example, I just wanted to give a real world example. So this is some code that I use for our open source project office to pull some data down from GitHub. It does a GraphQL query against GitHub and writes that data to files. So we've got here quite a complex GraphQL query, and we're posting that. And when it comes back, we're doing a lot of manipulation of the JSON payload that comes back and turning it into 2 separate files, which we've got up here in data. And this is running on my Mac. My Mac is what I use most of the time. but Visual Studio Code has an option to use a Docker container to develop in. It's a concept called dev containers, and it's standard within Visual Studio Code. So we now have a dev container using the VoltMX Go EA VoltScript dev container from Harbor. Again, I've got my atlas.json at the top level in my project, and I'm pulling down some dependencies. I'm pulling down console colors so that I can prettify the content that comes out in the console here. Obviously, I'm dealing with a GraphQL query, dealing with data that's coming back, and so I need JSON VSE. I don't want to store my token in my code here, so I'm getting that from an environment variable. And for that, just to show using something else, I'm using OS utils. I need to write files, so I use stream.vse for that, and I need to make a web service call, a REST service call, so web.vse. So I've converted this Node.js, which is about 230 lines, and as you'll see, it's a bit longer here, but that's really because when it comes to JavaScript dealing with JSON, you can use dot syntax a lot, and that's not as easy to do in other languages like Java and VoltScript. So, but here we've got the information that's creating that request. We're then processing the JSON and converting that object, and then back up in the sub-initialize, which is what automatically gets triggered from a .vss file. We're making that initial call for 50. It's then going to recurse for all of the data, and then we're opening a stream, writing a file, closing the stream, opening another stream, writing the file and closing it, because as every good geek knows, we should never cross the streams. So let's run that. And it's running through, generating those, making the next request and the subsequent requests to GitHub. And it's now written out the files. If I just refresh this, we've now got the outputted data, JSON data formatted in a completely different way. So we'll just go back to the slides now. So just to recap, what do you get for EA1? Well, there's quite a bit there. There's a native Windows runtime. There's a Docker image for native Mac development, some major language enhancements, 2 Visual Studio Code extensions, 10 VoltScript extensions written in C and C++ up on the VoltMX Go marketplace, 4 new VoltScript library modules, dependency management to pull those down so that you don't have to copy and paste files around and set your configuration manually, full API docs for all of that, detailed documentation for all of those, as well as ready to go samples. That program is available today, so it's ready for you to get started. And back to you, Adam.
Great, thank you. And I see several registrations have already come in over the course of the webinar. Please go ahead and register, and you can get started on it right away. We do have some questions that have come in. The first is, I saw in the try-catch structure that you guys used exit sub. Is that really necessary?
Exit sub is still supported, it still works great, There are other ways to exit. You can use the return statement to exit now, or you can simply let the code run out as it ends, depending upon how you've designed your sub or your function, whatever your method is. We really don't have a recommended way at this point, but the new return method, I don't know, I think Ed covered that in detail. It's a new method, or a new command, and it immediately ends execution of whatever that method is and returns to the calling code. So it's similar to an exit sub, except if you're in a function, it returns value, and if you're in a sub, it simply ends. So it's a new feature, but exit sub or exit function is still supported.
Great, thank you very much. We should have said we have several others beyond the speakers you heard already on the line to answer your questions. We have all the experts here. So please keep the questions coming. I've got a question about what is the recommended alternative for rich text in Volt and VoltScript. Paul, do you want to take that one?
Yes, so I did some investigation a couple of years ago about rich text on the web, and it's a very interesting and illuminating and at times worrying scenario. It's really going to depend where that content is being edited, because a lot of the more modern rich text editors won't just take a load of HTML. Some of them only accept data in a JSON format that is proprietary to that editor. It's going to depend upon how it's being used. It's going to be very difficult to get a standard format for everything. In VoltMX Go, the summer note editor is what's being used, and that tends to take some fairly nice HTML. So that's going to be the option that we'll be using within VoltMX.
I can expand on that just a little bit. This is Bob. If you're wondering how to deal with rich text in script, you have a couple of choices. You can use the Notes backend classes to convert it to plain text. The Notes rich text item already does that. Or you can, in VoltScript, you can use Keep VSC to basically use REST API to Domino server to collect MIME data and deal with that in script. So we can give you a couple of options there.
Okay, great, thank you. We have a question about where the dev container and Harbor are located. Are they on an HCL website or are they on HCL's GitHub site?
This is Paul. It's the official HCL Harbor site, which is where you would have got the VoltMX Go early access. That's hclcr.io, and it's under the VoltMX Go EA project.
Very good, thank you. We've got a big picture question. Where are these neat VoltScript functions going to run in a production environment?
I can answer that since no one else is jumping in. Again, it's Paul. So our target for GA is going to be running on Foundry as REST services, as snippets of code to manipulate inputs and outputs. So for example, to pick up credentials for a SQL database so that you don't store them up on Foundry itself. You just pick them up from an environment variable, for example, that kind of snippet of code, and possibly for workflow functions as well.
Okay, thank you.
And this is Devin. I want to expand on that just a little bit. Asking where they're going to run in a production environment, that kind of depends upon what your production environment is going to be. We're starting with Foundry. That's the that's our target environment is for VoltScript to run in Foundry. But where can it run? It runs at command line level on a local machine. You could throw it into other things. So it kind of comes down to what you want to call your production environment. As Paul said, our target is Foundry, and that's because it's designed as middleware. So that's the purpose of it.
Okay, thank you. We've got a question about whether LotusScript that can, whether you can run LotusScript that connects to ODBC data sources using LC-LSX.
I can take that one. The
Yeah.
answer is yes, because that LSX, at least the 64-bit version of it that comes with the server, is consumable by VoltScript, same as the notes backend classes. It's not that we're suggesting that is a recommended thing to use, but if you need it, it's available.
Okay, great, thanks. Next one, does this run VoltScript in the same way LotusScript runs, or is it converting it to JavaScript?
It is not converting it to JavaScript. It is the LotusScript engine, is the core DNA of VoltScript. It's the same compiler, enhanced, and runtime enhanced as LotusScript.
Okay, great, thanks. Can you expand on running VoltScript via command line? Is it similar to running batch files?
Yes.
Yeah, I'll let Bob take that because that's how Bob built it. Go for it, Bob.
Yeah, it's a on Windows it's an exe, and on Linux it's a Linux executable. You can run it from the command line, or you can run it from VS Code, as we were doing in the demos. Same thing.
Great, thanks. Can you share some functional changes or the next big changes you're planning to make to the language from here? What's next for VoltScript through the early access?
Paul?
One of the next things in the VS Code extension is we're looking at hooking it into VS Code's debugger. We're still going to be needing to make enhancements to a lot of the LSXs, so that's a chunk of work. And getting started on running it within Foundry. We've done some proof of concepts, which you may have seen at Engage and CollabSphere, but we've still got a lot of work to do before next year, so we'll be diving into that.
One of the things, I may get slapped down for this, but I don't care. This is important. One of the things that we have discussed, and we're still trying to figure out the best way to handle it, is a native logging mechanism that's secure, that works, that can be accessible from any code running VoltScript. We've kind of discussed this. We're still trying to figure that out. I personally think this is something very, very important, but we've got a lot of chewing and internal discussion to figure out the right way to do it. So that's one other thing that's being thrown up on the wall.
Okay, thanks. I've got a question. Are there any limitations on what we're allowed to do with the VoltScript early access?
So I'll go ahead and pipe in here. This is Michael Alexander, and I want everybody to do a lot of interesting things and push the limits and give feedback. So the question about what next features, I'm really eager to hear what features you would like, what your demand is. As to limitations on what you can do with it, I will say that this is early access code. This is not code that is expected to go into production for you today. This is a first release of this. It is not something that I assume you will never be able to find a bug with or never be able to come up with requirements and requests for. We need to work together to make sure this meets your needs. And that's why we want to make sure that it's available sooner rather than later. I know that the team here has put heart and soul, blood and tears into this, just as everybody on this call has actually spent a lot of time with VoltScript and really has incredibly valuable solutions that already exist in an environment. So coming back, rolling into when you can use it and what the limitations are, I'll put your personal comfort level on how serious the particular project you want to implement is right now. It is not fully supported, call and get a fix immediately level release. This is early access. Having said that, I believe in this code and the team believes in this code, and this product as early access is still valuable to start building on. Hope that helps.
Yeah, and just to echo what Michael said, please do share your feedback. We've got a forum set up where you can ask questions and provide your feedback. And the whole reason we're doing this now is so that we can understand what it is you want to do with it and see how we can start to incorporate that in now or in the future. So please head over there and as you start using it, share that feedback with us.
And the whole team is in the forum and we'll see it. So it's not some black hole.
Next question, will Domino Designer one day be VoltScript's target?
Haas, I'm the product management director for VoltMX and MX Go. So I'll take that answer. So the current target for VoltScript is, as mentioned, to run as part of Volt Foundry and part of VoltMX Go. So that is the current target. So we are not currently looking at making it part of Domino Designer, but we don't know. Depending on the interest and stuff, things may change in the future. The current target is VoltMX Go.
Okay, thanks, Suhas. I think that just about wraps up the questions we have. We'll give a pause for a minute. Maybe you can go to the next page here and we'll see if there are any last questions. As I mentioned, we will have a webinar coming up on what's new in VoltMX Go v201 once that is released. So stay tuned to your email and be on the lookout for information on registering for that. We also want to make sure you all know that you can try VoltMX Go on the HCL Sophie platform. This is a hosted environment where in about 10 minutes, you can be up and running with a VoltMX Go instance that you can use access to Foundry, access to the Domino REST API, access to a hosted Domino server that you can connect to through your Notes client. You can move your own NSF files there and access them or try importing them into Foundry using the design import tool. You can connect Volt Iris to it and bring your applications in or try it out. So if you've been holding off on trying MX Go or haven't had a chance to do it yet or didn't want to go about setting it up, we've done all that heavy lifting for you. You can see the QR code there, or you can go to, I believe it's hclsophie.com and look for VoltMX Go there. And I'm not seeing any other questions come in. So with that, I'll see if anyone else on the team has any closing thoughts. Otherwise, well, thank you all for your attendance and look forward to talking to you all.